In this video, you will learn how to implement an on-screen logger, just like the one in Unreal. In this video, you will learn how to implement the Gui method to draw simple widgets to the screen, how to use the Streambuilder class to create strings in a more optimized way, get log callbacks, so when someone uses the debug.log or log warning methods, you will retrieve that text, how to create a custom find index method, and how to create a custom sort method for arrays. So I have created a new project and we are going to create a new script. Let's call that debug test. In here we're going to, when we press different keys, add different logs, so we can use that to test our on-screen logger. So when I press 1, I will log an information message. When I press 2, I will log a warning, and when I press 3, I will log an error. And the information I will log is just the time. Like so. So save that and go back to the editor. And let's place this component on the camera. Control P to play. And see that it works. Yep. The next step is to create the onLogger screen class. So we can start working on the actual visual logger. So let's create a new script. Let's call it on-screen logger and open that up. What we will do here is hook up to the log message receive. So we will actually get a notification when a log is written. And we will subscribe to that event from on enable. And then we should remove our subscription to that event on disable. And to subscribe to that event, we go via the application class. We have log message received and log message received threaded. The first one is messages only done on the main thread, and log message received threaded can also be logs made from different threads. So in this case we're gonna go with threaded and plus equals to subscribe, and then we need to enter a method that is going to be called when we receive a log. So let's create that one here. We can call it handle log. Of course, let's spell that correctly. So to be able to use this method, we need a few parameters. We need the actual text that is logged. We will receive the stack trace and the log type. And the type is an enum with error, assert, warning, log, and exception. So now we can say plus equals and log, like so. and on disable, we will stop listening to that event. Let's make sure this works. So let's add a breakpoint here. After that we need some form of instruction. F9 or click here. And let's do a attach to Unity editor. Let's add our on-screen logger to the main camera. Let's try it out. Here we go. So now our breakpoint is breaking, and we have a log string, a stack trace, and a log type. The next part is creating a data type to hold information about our log entry. So we are going to create a nested data type, and it's going to be a struct. And we can have that as private, as we're only going to use this inside our on-screen logger. We need to know about three things: the text, the log type, and the kill time. And the kill time is at what point in time this message will no longer be on screen. So let's create properties for those. So we're only allowed to set those values inside our log entry struct, but we will be able to retrieve those values inside of our on-screen logger. Let's also do a public method where we can set these values. Duration will be the amount of time where the log message will show, and let's have a default value of 1 second. And here we're just gonna set those values. And kill time will be current time plus the duration. We will also need a reset. And let's just say kill time equals -1. And we will call this because we're going to reuse log entries instead of creating new ones all the time. And if we have hit our maximum amount of log entries, we will take the oldest one and just reset it so we can kind of reuse it. Now we need to create our actual array of log entries. We also need to know the size of it, and that is something we're going to expose in the editor. So let's add a header. Let's say settings and do a private int capacity. Let's have a default value of 8. And for this to, of course, appear, we need to give it the attribute serialize field, as it's private. We're also going to add a tooltip to explain this to the one setting that up in the editor. So let's say max amount of log entries. And then we need our actual array. So private log entry. Log entries. and in awake, let's set log entries to new log entry and add capacity here. To explain our array, we will have a list of entries, each one with a specific kill time. So if the current time is 10, our entries might say with kill time, let's do kill time 15, 20, 30. So the time here is taking place after the current time, so these will still be visible. So this part will be sorted. At the bottom of the list, we will have available log entries, because the time here took place before the current time. So these will be invisible and log entries that we can use. So let's start planning our handle log method. So what we will do is check if the entire array is filled with valid log entries. And if that's the case, we are going to take the oldest one that is at the top of our array and reset that. Then we are going to sort our array. And then we are going to find the first index of a reusable entry. And we are going to build our string. And then finally set the log entry with the new information. So what we will do here is check if the last entry of our array still should be visible. If that is the case, we will reset the top entry, the first log entry, since that will be the oldest one because our list is sorted. And now we can remove this part. To sort the array, we are going to use the built-in sorting method, but use our own sorting algorithm. So to be able to use that, we need to go to the top and say using system. And then back here, we are going to do array.sort. And here we can have our array. Insert that one, which is log entries. And then we can give it a method to use to compare our values when it sorts. So let's implement that down here. And let's make that private static, and it will return an int. Let's call it sort entry comparison. it will take in two log entries so they can compare it. Log entry A and log entry B. And let's make sure that we will use that here, like so. As we can see, our sort entry comparison method returns an integer, and depending on the value we return, the different entries will sort differently in our container. So if the return value is less than 0, that means that A will precede B. So A is considered to be a lower value than B. If the return value is 0, that means that they don't have to change place. So A and B is considered to have the same value. If it's more than 0, that means that B should precede A. So they will swap places in the container. We will use this to compare the kill value of our log entries. So let's begin with A. If the kill time is less than the current time, it should still be visible. And let's compare that to B. So if the kill time of B is also, if that should also be visible, let's return 0, meaning they don't have to swap places. But if the kill time of A should still be visible and the kill time of B doesn't, it has already been killed, then we return 1, meaning that we will push B to be in a later position in the array. And if the kill time of A is after the current time, we check that if the kill time of B is ahead of the clock, meaning it should still be visible, and we return -1. Otherwise, we do a regular comparison between A and B, which works the same way. So this will basically make sure that valid log entries that should still be visible is sorted at the beginning of our list, and the log entries that has already been killed or shouldn't be visible ends up at the bottom of our array. So now we're done with sorting the array. Now we should find the index of the first reusable entry. So we're going to use a built-in method for that. Let's remove that, called array find index. And here we will use a custom predicate to find a valid reusable log entry. So of course we are going to look through our log entries array, and we need to create the predicate. So that could be a private static pool. Let's call it available entry comparison. It needs a log entry. And will return if this is valid or not, if we can reuse this or not. That is, if the current queue time is less than the current time, means it should be visible, otherwise it is reusable. So now we can feed that into our find index method here, like so. The next part is to actually build the string that we want to display, and for that we're going to need a few more variables. So up here, let's add one that we don't actually need right now, but we're going to need quite soon. Let's give it the shell as field attribute. This is going to be the amount of time each log entry will be visible on the screen in seconds. Let's give it a default value of 1. And we can of course clarify the tooltip just to be super clear. Then we need to have, we want the one using our system to be able to say if they want to print out the type of message and the stack trace or not. So let's do a public bool so show log type. So this will basically print out log, warning, error, and so on. And let's add another one for stack trace. Let's do false by default. We also need a few colors, so we will print parts of it in different colors. So the warning, which is in the console, is yellow. We will print the warning log type in yellow as well. So let's add a new header and say colors. And let's move that part to be capacity. Okay, so the colors we need are background color, because we will have the text over a background, so it's more visible in the scene. Let's do gray for that one. Let's have a public color for text color. Let's do white. Log color can also be white. Let's do yellow for warning. Red for errors. And red for exceptions as well. Let's actually do a read in here so we can collapse that. Like so, and now we can just go like that. And let's go back to our build log string. So we will create different methods to help us to keep the handle log method cleaner. So let's do a private void build string. The information we need to send in is the log string. Let's send it out as an in parameter, meaning that we will send it as a reference, but we can't modify it. So in string log string, let's do the same for stack trace. In log type, and finally let's have an out parameter of the actual final text. To build a string, we could of course concatenate them the traditional way. But the issue with this is we are performing heap allocations every time we do equals or plus equals and so on, which is expensive. So what we could use instead is a class called Streambuilder. And to use that, we need to be using system.text. And then we can create a Streambuilder object instead. Let's call that text. Now the Streambuilder class of course isn't perfect either. One of the issues is in this particular case that we don't know the exact size of the text. That means we potentially will waste space having a capacity of the text to be higher than the one we need, or even worse if we have too small a size and then we outgrow that size, so we have to expand the text all the time. So in this case we could go for a higher capacity, wasting memory instead of having to expand the Streambuilder instead. So we could just leave that by default. We could just give it a size. So I'm just gonna leave this like that, and of course you have to kind of measure the performance in your particular case. But let's try out the Streambuilder class. So if we want to show the log type, if that is true, we are going to append some text to the Streambuilder text variable. And we want to show the text on the screen in a certain color. So we can use rich text formatting. And to do that, we can go color equals $, and then we are going to append the actual color value. And here we can use the color utility class to convert a color to the HTML format of color. So to HTML RGBA, and instead of doing a big if case here, messing our build string method, let's create a new method that returns the color, and it's called get log type color, and send in, you can do that as an in parameter as well, log type. So in here, let's do a switch case. based on the type, the log type. And let's see if the log type is log. Let's return log color. If it's warning, let's return warning color. If it's error, we of course return error color. And default or case log type dot exception, let's just return exception color. Then we pass that in here, so get log type color and pass in our type from here. Let's see, so after that we need to append that one, closing this rich format text. And then we append the type, because this is what we want to show, if show log type is true. Then we append a colon, and then we close the color so it doesn't affect the, any text coming after this. So we do that by saying that. And then finally let's append a tab. After that we want to show the actual text, so let's do a text.append, and we want to use rich text format again, so color equals £, and here we want to send in the text color, and then close down the color, and then we append the actual log string. And we need to ask if we want to show the stack trace. That is the case. We first append the log string, and then we append the stack trace. Otherwise, we just append the log string. And finally, we close the color, and then we need to give our out parameter final text the final string. To do that, we go final text equals text to string. In case you're unfamiliar with the HTML string version of a color, let's just do a quick explanation. So with RGBA, you have R, red, green, blue, and alpha. Those are the 4 color channels. If you only have RGB, of course you only have red, green, and blue. So that could be red equals 1, green equals 0, and blue equals 0. Means that the and color is red, because the red channel is fully on, green is 0, and blue is 0, meaning you have only the red color channel being at the fullest amount. You can also have like 0.5, 0.5, 0.5. This means that all the color channels have half their value. This would lead to like some form of mid-gray. If everything is 0, that means all color channels are off and you have black. For HTML colors, that is basically hexadecimals. So that would be, for red, you have FF, that is basically the corresponding value of 1, 0, 0, 0, 0. So basically you have red, green, blue, and alpha. So to have the color black, you go 0, 0, for instance. So what the color utility to HTML string RGBA means, they convert it from this format to that format. The last part of this class is to actually draw the strings. So let's see, we are going to use a method, a built-in method, which is actually Unity's old legacy GUI system that is still left here, which is great for doing things like this. Let's start with adding a private member of the type GUI style. Let's call that background style. Let's spell that correctly. So the GUI style is explicitly used with the onGUI method that we are going to use. So here you can define different ways of rendering texts and what sprites you should have for background and so on. You could expose this to the editor and let someone else like fill that in, like what's the size of the text, what font you want to use, and so on. But we're just gonna keep it simple. We are going to do two things in Awake here. And that is to set the background texture for, let's see if it's actually for normal. So normal is the normal state of this style. We also have, let's see if I remember, I think like a hover and things like that. We're going to use normal and background. And the background is actually a texture, and we are going to color the background. And you can set a color here, but we can tint the texture instead. So what we want to do to be able to fully tint this is to have a white texture. And you don't have to create a texture and set it. You can just ask the texture 2D class for a white texture, which is 1 pixel size texture, I think. So you go like that. And what we also need to do is enable rich text, so we can actually have colored text parts and so on. And let's jump down here and implement onGUI method. So the onGUI method is, like I said, Unit's old GUI system. It used the style of it was immediate mode, which basically means you have to do it in code, except for the style. But basically you say, okay, I want a button, and if that button is pressed, do this. So their new GUI system is of course a lot better. It's event-based and all that, and you can actually see it and work with it in the editor instead of doing it all by code. The onGUI method is potentially expensive, because it will Unity will execute the on Gui method on all components that implement that for every input. So during a frame, if you press A, B, and C, it will run 3 times on all components that implement the on Gui method. And that is potentially very expensive if you use it a lot and have a lot of input. So here, for instance, we can ask the GUI class. You have GUI layout, and so on. You can do a lot of things with it. It's just really messy code. So for instance, if we want to have a button, we have to first ask, okay, is this button currently clicked? And then we can go GUI button, and then we see that we give it a rectangle, that's the position and size of it, and GUI context or a string, that is the text that is on the actual button. You can give it a texture and so on as well. So to have a button, let's do a new rect. So let's do 5 on the X position, 5 on the Y position, and 100 in width, and 100 in height. Let's give it a text. And if we do so, let's do a debug.log. Let's say clicked. And let's go over to the editor. And now we have this button, and when I click it, we log a clicked message. So that is how you used to do it. And you could use fully game UIs using that system. I, for instance, made an inventory system for an RPG, and that was not fun. And to make it scale with the resolution, it was just terrible. So I'm really thankful for the new UI system Unity uses. So of course we are going to draw our log entries, and the GUI class is kind of like a state machine. So we can set the color currently, but we also need to reset it just to be kind to any other classes that might use this. So let's do a color, a local variable, previous color, and we are going to change the content color. That is the color for the text. And at the end on the on GUI method, let's set that back. So in here we are going to draw our log entries. So let's begin by setting the background color. So GUI background color, and we have our background color variable. Then we're going to use the GUI layout. Here we can have a begin vertical and give it our background style. So this is basically the box, and the reason why we use a begin vertical here is so we don't have to calculate the position of each log entry. The GUI system does that for us, which is nice. But that means we also need to do a GUI layout end vertical. And everything we add here, every widget, will be placed, and like the position and the size will be calculated for us, so we don't have to do that. And then we're going to loop through our array. So let's do a for. Let's do a log entries length. So for every entry in our array, we're going to draw something. And here we need to make sure that we don't draw things that should not be visible. And that means if the current entry, if the kill time is less than the current time, we should not draw that. And then we can of course use the continue, meaning the loop will not execute our code here, but will continue on to the next cycle of the loop. Otherwise, let's do a GUI layout and label for just a text, and let's do a log entries dot text. Like so, and this is it. So let's go out and see if that works in the editor. So if I click 1, 2, and 3, it should create the labels here, which it doesn't. So let's take a look at what we did wrong. Okay, so what we missed is down here in the handle log. Of course, we need to actually build the string and set the information for that log entry. So to build a string, we go build string and send in the log string, the stack trace, and the type. And then we need a out perimeter. And of course we could go string text and send out text like that. But we can also do a inline out perimeter. That means we remove this part here and do like that. Now this string is local to the handle log method, so we can use it outside here. So this is defined and we can use it here. So this is called an inline out perimeter. And to then set the information to a log entry, go log entries, and of course we use our find index here, but we didn't actually retrieve the information. It returns the index of an available element. So let's do an int index equals, like so. And since we did this, we are guaranteed to always have at least one valuable valid index. So let's give it the index and then call set log entry, and we want to send in the text, the log type, and the duration. And we had a on-screen duration field exposed in the editor, so we could use that. And let's now go back to the editor, and it should all work fine. And if we change the on-screen duration time to, let's say, 3 seconds, and let's also show the stack trace. This is what we get.